Right now, somewhere past the moon, there's a small spacecraft drifting silently through deep space. It cost $3.5 million. It was built in under 10 months by a startup that wants to mine asteroids for platinum. It made it farther from Earth than almost any private spacecraft in history. And then, 20 hours after launch, it went quiet. And it has never spoken again. This is the story of Odin, the first real private attempt to go prospecting in deep space. What killed it, and why the company that lost it says the mission was still worth every dollar. In the next few minutes, you'll learn why anyone would gamble millions on mining a rock in space. What actually went wrong in Odin's first 48 hours, hour by hour, because the company published a brutally honest autopsy. The strange story of a German amateur radio operator who became the mission's best ground station. And what's launching next? Because this story isn't over. Let's get into it. First, the why. You've probably seen the headlines about Asteroid 16 Psyche, the metal-rich monster NASA is flying a probe to right now, arriving in 2029. Psyche's metals get valued at $10 quintillion. That's a 10 with 18 zeros. And that number is basically meaningless. Dump that much metal on the market and prices collapse. It makes headlines, not business plans. The real business case is smaller and smarter. It's about a family of metals called platinum group metals. Platinum, palladium, iridium, and their cousins. They're essential to electronics, catalysts, and clean energy tech, and they're vanishingly rare in Earth's crust, because when our planet was molten, most of the heavy metals sank into the core, far out of reach. But certain asteroids, the shattered fragments of ancient planetary cores, carry those same metals right at the surface. A modest, metallic, near-Earth asteroid could hold a concentrated supply. You don't need to drag home a mountain. You need to find the right rock and bring back the right tons. But here's the catch that makes this story interesting. Nobody has ever confirmed, up close, that a specific small asteroid actually is metallic. From Earth, a telescope sees a faint dot of reflected light. You can guess at the composition from its color and brightness, but a guess is all it is. And an entire business model hangs on that guess being right. Before you can mine anything, before you can raise the serious money, before any of it, someone has to fly out to one of these rocks and simply check. That unglamorous first step, go and look, is the entire reason Odin existed. A California startup called AstroForge built Odin to do exactly that. Fly past a small near-Earth asteroid called 2022 OB5 and photograph it to test whether their models had really found a metallic one. And they built it in a way that would horrify traditional aerospace. Less than 10 months. About $3.5 million. For comparison, a NASA small spacecraft flying on the very same rocket, Lunar Trailblazer, cost about $95 million. Odin was built for roughly 7% of that. How is that even possible? By accepting risk on purpose and being shockingly public about it. Before launch, the company gave its own mission, just a 30% chance of success. Sit with that. They told the world they'd probably fail. They knew the battery only held about 2.5 hours of life if the solar panels failed to open. They knew testing before shipment had flagged a possible issue with those very panels. They knew the radio's power amplifier wasn't configured to switch on by default. These weren't secrets that leaked out afterward. The company listed them itself. They launched anyway, because their whole philosophy is that you learn faster by flying than by polishing. Their founders came out of the rocket world, And one of the lessons they'd absorbed the hard way is that the experience doesn't transfer cleanly. Building a spacecraft, it turns out, punishes you in completely different places than building a rocket does. The only way to find those places is to fly. You can argue with that philosophy. Plenty of aerospace veterans do. But you can't call it dishonest. They published all of it, before and after. February 26, 2025. Odin rides a Falcon 9 to space and separates flawlessly, right on its deep space trajectory. And then the mission starts dying. Not in one dramatic explosion, but as a cascade of small, unglamorous failures. In the first 8 hours, the golden window, when the spacecraft is closest and the battery is freshest, the primary ground station in Australia breaks down. Then it gets worse. One station, it turns out, is transmitting with the wrong antenna polarization, so for the first 4 hours, nothing goes up and nothing comes down. Another station has incorrect pointing coordinates. A third lost a power amplifier the day before launch. A fourth is drowned in noise from a newly built cell tower next door. Nearly every dish in the network fails in some way. The spacecraft might be fine, and the ground can't hear it. Then, 7 hours in, a signal, but not from mission control, from a man named Peter, an amateur radio operator in Germany with his own 22-meter dish, who picked up Odin's faint call on his own time, for free. Odin was alive. It was trying to talk. The company later said this volunteer was, in their words, one of the most reliable ground stations they had, and underneath all of it ran a quieter problem almost nobody talks about. There aren't enough big dishes on Earth. Deep space communication runs through a small number of giant antennas, and every mission in flight is competing for time on them. AstroForge described literally jockeying with other organizations to get on and off the dish. And when another mission needed 1 more hour, that hour came straight out of Odin's shrinking window, costing precious degrees of elevation before the spacecraft set below the horizon. Their blunt conclusion: the world's deep space infrastructure is already stretched to its limits, and the new wave of private missions is stressing an old system that was never built for this many players. There were real victories in those hours, and they deserve their due. The team did establish two-way communication, commanding the spacecraft roughly 124,000 miles out, a feat requiring a 32-meter dish pointed within 0.15 of a degree of dead center. Miss by that hair, and you'd never hear a whisper. And, by crossing beyond the moon on an escape trajectory, this tiny startup became, by its own account, the first private company ever to talk to a spacecraft moving fast enough to leave Earth's gravity behind for good. But the evidence suggests Odin had booted into a protective, sun-safe mode, probably because its solar panels never fully deployed, starving it of power, possibly leaving it slowly tumbling, its antenna only sweeping past Earth by chance. That pattern actually fits the data. Brief, teasing contacts early on, then nothing. 20 hours after launch, last confirmed contact. The team fought for days. More sensitive receivers, borrowed telescopes, round-the-clock shifts, engineers sleeping in travel trailers they'd pulled into the loading dock. Telescopes tried to spot it optically, but Odin sat too close to the sun's glare to see. And here's the cruel geometry of deep space. The farther Odin drifts, the more its possible positions smear out across the sky, and the harder it becomes to know exactly where to point a dish whose beam is smaller than the moon. The spacecraft is still out there, on its predicted path. Nobody can reach it. So, total loss? Here's the counterintuitive part. AstroForge says 99% of the mission's value was banked before launch, learning to build, wire, and test a deep spacecraft at all. That sounds like spin, until you look at what they actually changed because of it. The failure got converted, line by line, into engineering rules for the next vehicle. Future spacecraft will boot up screaming, automatically broadcasting a beacon the moment they wake, in small, loud packets, so even a crippled craft can be found and tracked. Ground stations will be assumed unreliable. At least 2 independent stations verified before launch, with the company running its own checks instead of trusting anyone's paperwork. Spacecraft will be tested in their exact flight configuration, down to simulating the faintness of a deep space signal, the kind of testing Odin's 10-month sprint never left time for. And early missions will be radically simpler. Prove the spacecraft lives, then get ambitious. The transparency paid off too, in a way that's easy to miss. Because the company narrated its failure in public, the world showed up to help. Amateur operators scanning for the signal, observatories volunteering telescope time, roughly half of the last-minute strangers they asked for tracking help actually saying yes. In an industry famous for secrecy, the open door became an asset, and the successor is already in the works. It's called Vestri, targeted to fly with a lunar mission in late 2026 or early 2027, and it's a different class of machine, 200 kilograms instead of Odin's 120, electric propulsion instead of chemical, nearly 10 times the electrical power, and landing legs. Because Vestri isn't planning a flyby, it's going to attempt to land on that same asteroid, 2022 OB5, and measure the platinum group metals on its surface directly. Investors didn't walk away after Odin either. The company reported $55 million raised, with backers doubling down after the loss. In this corner of the space industry, a dead spacecraft isn't the end of the story. It's tuition. So the first private prospector is lost in the dark, and the second one is already on the assembly floor, aimed at the same rock. Maybe it lands, maybe it dies too. But someone will eventually confirm a metallic asteroid up close, and the moment they do, a very old question becomes very real. How do you actually turn a rock in deep space into refined metal in a warehouse on Earth? The answer is stranger than you think, and it's where we're going next time. I'll see you there.